Hello everyone, with another video related to vectors and vector components and adding vectors. So in this scenario here, I have four vectors acting uh, on the same point. Let's say it's at the origin point. Each vector have different magnitude and have different direction. We need to find the resultant or the total of all these four vectors together. So the best way to do that is to handle each vector individually at the start by finding the x component and the y component for each one of them. So what I designed here, a table to help us to do that maybe in a faster way instead of like draw on the actual um, vectors, which gonna make it really crowded with so many arrows. So for the x component of the vector A, we can see the angle is 60 degrees, which mean the adjacent will take the cosine. So here we can say it's going to be A cosine 60, and what we're going to do, simply we're going to say, all right, it's a 15 cosine 60, and that will give us 7.5, and we know it's going to the positive direction. Now for the y component, it will be the opposite, which means it's going to be A sine 60. Once again, it's 15, and that will give us, we can say it's 13 units positive. All right, that's for the vector A. When we go to vector B, I can see it's directed exactly to the east, which means the angle between the vector and the x-axis is 0. And in this case, the component will be the adjacent again, the cosine will be the x-axis. So the x component of vector B will be b cosine 0 degree, and that simply will be the same value at 10, and it will be the same direction. So if we're going to take the opposite component, which is the y component, it will be b sine 0 degree, and that will give us 0, because sine is 0 is 0. All right, now let's go to vector C, which is luckily going to the y direction, negative, or to the south. Again, the angle between the vector and the y axis, it's 0, which means um, if we're gonna deal with it and apply the formula, that will be b. Sorry, not b. It's the c vector here. Okay, so it will be c sine 0 degree, and again that will give us 0. However, for the y component, it will be c cosine 0 degree. Cosine 0 is 1, and that will give me 25. And remember, we mentioned that in our previous videos, the direction of the cy component is going downward. So I will give it the sign negative, so I don't forget that. Okay, let's go with the vector D. D, we have two different ways to handle that, as I discussed that in previous videos. I could take the angle 28 of west to south, and I need to keep in mind that I'm quadrant 3. In this case, the sine and the cosine will be both negative, and we can see also they're both going to be on the direction of negative, the negative x and the negative y. Or I can take the full angle where I have the 180 plus 28, which is 208. In this case, the cosine the cosine will be the x, and the sine will be the y, and we're gonna place the value as cosine 108 or sine 208. But I will do the 28 for this time, so it will be d cosine 28 degrees, and here will be d sine 28 degrees. Okay, now we're just gonna do the math or the calculation here. 50, that will be 44, but the direction is going to the west or to the negative, so it will be a negative here. Now for the other one, for the y component, it's giving me 23.5 almost, yeah. And again, it's going to the negative y axis. So we give the y, that value, the direction minus. Now, I managed to analyze all these four vectors into their components, the horizontal and the vertical components. Now, I need to add all x components together, all y components together to be able to have only two components which they will take me to the resultant. Okay, so if we're gonna add 7.5 plus 10 minus 44, that will give me minus 26.4 units. And for the y-axis, I have 13 minus 25 minus 23.5, and that will give me a negative 35.5 units. So now I have the final total y components and the final total x components from all these vectors, which mean I can calculate the resultant. So it is the Vx total squared plus Vy total squared for the y component equal. So what we're going to do, 20.4 under square root. That gave us 44 units, the total resultant of this system of four vectors. Now I could add one more thing to this example and try to find where is the direction of this resultant, which is can be done easily. Let me take this out, the resultant. We're done with this part. So to find the direction of it, let's see how we can do that. Now I can see that the total x components going to the negative, so that's the Vx total, and also the y total components also going to the negative, so I can go down there. That's the Vy total, which means the resultant will be from tail to the head. That's our resultant, which we already just calculated, the 44 units. That means this is our theta. It will be off west to south. That's one thing. I can tell the direction. If I want to find the exact value of theta, it will be simply by theta equal the tan inverse of the Vy total over the V, sorry, the V, let's just fix that part, the Vx total components. So just work it out, replacing, using these values here, and you will find how much is that exactly angle of west to south for the resultant. Okay, this is the way how you can handle if you have multiple vectors acting at certain point and you've been asked to find the resultant of all these vectors together. Simply you have to handle them individually and find their x and y components, then you can add all the x components together, all the y components together to end with only two values. One is for the total x component, one is for the total y component. Apply it to the rules of the resultant, you will have the resultant. In terms of the direction of the resultant, simply you need to draw maybe like a simple diagram like the one uh, you have here. Um, just make sure you follow the direction of the negative x, negative y, whether it's positive or sum of negative, and then you can find it by using the tan inverse of that of these two components. Okay, I hope this video useful to you, and I will see you again with a similar example where I have more like another maybe two sets of vectors or something like this. You need to add them to find the resultant. Thank you.